The application to several case studies in different countries has been fundamental for the validation of the new assessment procedure proposed by PERPETUATE. Each case study has provided an exclusive occasion to face the problem of seismic protection of cultural heritage at different scales and present conditions. Both single monuments and aggregated buildings in a wide urban area have been considered. The assessment is aimed to both seismic prevention and reconstruction after an earthquake. In most of cases, relevant artistic assets were present, allowing to test the capability of the procedure to consider their interaction with damage in structural elements. An accurate probabilistic seismic hazard characterization has been provided for the considered sites, supported by in situ microtremor survey and array measurement for the soil characterization. Moreover, for each case study, the data related to the built information have been collected, including in some cases also ambient vibration measurements for the structural identification. The earthquake occurred on the 6th of April 2009 in L'Aquila, Italy, seriously damaged the cultural heritage with local or extensive collapses. In PERPETUATE project, two important monuments have been analyzed: Ardinghelli Palace, in which serious damage occurred to important frescoes, and Santa Maria Paganica Church, which collapsed almost completely. The case of Ardinghelli Palace has represented an exclusive occasion to validate the models developed in PERPETUATE project to both the analysis of global response and local mechanisms. In fact, the comparison between the simulated and real damage occurred has turned to be a key validation. To this aim, both nonlinear static and dynamic analysis have been performed. In the case of Santa Maria Paganica Church, some parametrical analysis performed on a 3D detailed finite element model have allowed us to interpret the complex reasons of the extensive collapses, mostly related to some invasive structural transformations, like the replacement of the original wooden roof with a heavy reinforced concrete slab. The results achieved are useful also to address the most suitable structural solutions to be adopted in case of reconstruction. San Pardo Cathedral in Larino was slightly damaged by the earthquake in Molise region in 2002. Damage occurred in those parts that were recently retrofitted. Nonlinear kinematic analysis performed on most vulnerable macroelements have constituted the tool for identifying the most meaningful parameters and addressing the plan for in situ investigations. Then, according to the procedure proposed in PERPETUATE for this class, the final assessment has been carried out by combining the results of a 3D finite element model aimed to evaluate the load distribution among macroelements with a full set of nonlinear kinematic analysis on each single macroelement. Colisei Palace in Ljubljana has been a very exclusive occasion to apply several diagnostic techniques, either destructive or not, because the building was not in use and authorities had to decide upon its restoration or complete demolition. Due to the poor state of masonry, mainly due to the moisture conditions and freezing towing cycles, results have turned to be an important reference to assess the effect of deterioration on mechanical properties. Unfortunately, the result of assessment has been that the building was not restorable, unless by adopting heavy and invasive interventions. So, finally, it has been demolished. The neoclassical school in Rhodes is very interesting because of the complex foundation system. partially realized over the debris of ancient pre-existing structures. The original results obtained by PERPETUATE on the problem of soil foundation interaction implemented in Tremory program allowed us to simulate their effects on the seismic assessment of the building. The Arsenal de Mini Road is a simple structure at first glance. However, it is strictly connected on one side to the huge defensive city walls, which give an eccentric constraint to the dynamic response of the building. The results obtained by different linear and nonlinear models, including also the soil foundation interaction effects, have been compared. In roads, also the Hessen Bay mansion has been analyzed. It is a historical building not in use at the moment and in bad conditions. The PERPETUATE assessment procedure has been applied completely, starting from the as-built information phase, enriched by a rigorous sensitivity analysis aimed to account for different sources of uncertainties. The final assessment by Tremory program has showed the actual safety level of the structure is too low and allowed us to identify the critical aspects of its seismic response. This turned out very useful for the design of the most effective and conservative strengthening solutions. Finally, the assessment of the Great Mosque in Algiers has showed how it is possible to integrate the results of different modeling strategies. As the roof system cannot be considered as rigid in its horizontal plane, the most vulnerable macroelements of this mosque are the internal arcade systems. To this aim, both nonlinear finite element models and macro-block models have been used, in order to have a cross-validation and define the final capacity curve and the performance levels. Algiers is one of the areas selected for the application of the procedure at urban scale. The Kasbah, included in the UNESCO list of the World Cultural Heritage, is made up of a very complex aggregation of buildings. About 150 buildings have been directly surveyed, promoting in this way a close collaboration with local architects and authorities. An in-depth analysis of the geometrical and structural characteristics of the buildings has been made, discovering interesting ancient constructive solutions and valuable artistic assets also in a rather poor environment. Local damage mechanisms have been identified, mostly related to the overturning of the facade, due to the foundation settlement and maybe in some cases to previous earthquakes. The Femi-Vlog Ideas tools, the latter originally developed within PERPETUATE project, have been widely applied. This allowed to get a quantitative assessment at territorial scale, useful for planning mitigation strategies and priorities of intervention. Moreover, 2 case studies at urban scale have been examined in Slovenia. The first one concerns the rural settlement sited in the western part of Slovenia in Bovec Basin. It is particularly interesting since it has been recently struck by several earthquakes. Thus, it represents an opportunity to validate the efficiency of the proposed methodology. The second case study in Slovenia is the old city center of Ljubljana. Its constructive features and state of maintenance are completely different from those of the Kasbah of Algiers, so providing a representative example for historical centers in European countries. Fragility curves have been obtained for the seismic performance on the historical center as a whole.
The main idea of this vulnerability study was to actually evaluate the seismic resistance of all city centers depending from different levels of knowledge, which actually the methods FAMIR that we applied for this study together with the university from Bath actually showed very efficient in predicting some particular failure modes failure modes that are going to happen, and actually help us in re-strengthening this building with some provisions that are not so invasive, mainly by tying the walls and preventing out-of-plane failure that during the earthquake in 1895 that hit actually all this area provoked most of the failure of the buildings.
This case study is particularly interesting because, as you can see, we have an earlier portion which is much more ancient and with lower number of stories, and the structures of the roof is much more original and faithful to the medieval construction characteristics. And then as we move closer to the city centers and to the rivers, the part of the array, we are instead having some houses that are characterized by a much higher level of alterations, to the extent that we have very large opening at the ground floors, and we have quite high openings also at the upper floors, which are more in line with neoclassical architectural styles.
Well, maybe if I may add, I mean, our case study comprehends the style of different styles from the 14th century to the 20th century. So this whole study will also help us to see how that building technique was developing and how it affects the seismic vulnerability of all city centers. So in that case, this will be additional value for this study.
Yes, and maybe we will try to go in one of them. Very good. One interesting feature. One interesting feature that can be pointed out is that these houses have already original ties in their fabrics, and these ties were usually included in the construction in order to tie together the walls, the facade to the party walls, especially, for instance, in this case where there is a gap between adjacent buildings, but also to connect the floor structures to the wall structures, and this again helps preventing the out of plane. These also point out towards the type of interventions that Vlatko was talking about before, and that we intend to include as a proposal for increasing the resilience of the whole city center to earthquake, using interventions that are very much in line with the original fabric and at the same time can substantially improve the overall behavior.
Because the main idea of this strengthening technique, applying different strengthening technique, is to actually increase the resistance for the return period of 100 years up to that level, so that you will not suffer some major damage. We cannot prevent the collapse of the structure with these minor strengthening techniques for the return period of 475 years. But certainly we can increase the resistance for probability of occurrence of seismic event, which is more probable than that.
Yes, and this is also important in the perspective of reversibility of intervention. We don't expect and we don't pretend that we can actually, that we have now the tools to prevent, to solve of the problem and ensure the survival of these buildings for the next 500 years. But we certainly know that with modest, relatively modest interventions and relatively light-handed intervention, we can reduce significantly the damage that would occur, and we
help the owners to how to strengthen it.